Hello, hello. Hello. My eyes. Super red. Holy moly. I have crazy allergies. And I think that's rather evident here. So, today we're going to take a look at Typefest. And I was thinking maybe we do something like this. And this guy. And then I think what I can do is that, and let's see if we get so what do I really care about here? Probably nothing. Interesting. It looks like you can't really, oh, I guess you can. Okay, cool. So okay. Cool. So that looks like it's working. So we can go through Typefest. Okay, and I think the easiest way to do this is just hello, streamer. I've checked your. Oh, thank you for reminding me to go to multi-stream. So your name is Angelica416, and it's also Danielle Sarah 123. Sounds good. So maybe we do that in order to add Typefest, and then if I do, oh, so this doesn't have autocomplete. Disable the automatic acquisition of types. Disable changing the URL when you type. Show the compiled JavaScript. Okay. Compiler errors. Yes. We don't need the output. And then manage those. Okay. I wonder what the difference is between these two. Oh, okay. So that you have to press, where that one happens on save. Okay. Oh, but that seems to like blow up. If there's an issue? Is that what's happening? Or there's just no plugins. Okay. No, that's not true. There are plugins. So interesting. I can't click plugins anymore. Okay, so primitive. Okay, cool. I don't know if this is just like the way my arms are, or if my arms are just big, but like I need to like move the arm rests farther, and I'm at the end of the theoretical limit of moving my arms. Why does this not work? Okay, so if I do that, does that get rid of the plugins? And then can I do this? No way. I just can't click plugins anymore. Okay, well then we don't really need that at all. Okay, so primitive, interesting. Class matches a class. So okay. Constructor matches a class constructor, abstract class, abstract constructor, typed array. Okay, and then an observable, and this is a proposal. Listen to an element and an event name. Return new observable. Create an event handler, which sends data to the sink. Okay, so it's a callback with an event, and then it just publishes an event to the observer. Attach the event handler. So add event listener to an event name, and then that's the callback, and then true for bubbling, I guess. I can't quite remember what that value is, which I think implies that you should always have. I need to take clarity. Look at my eyes. Implies that you always need to have an object parameter because it's hard to know what that value is. Return a cleanup function that will cancel the event stream. Okay. So you have a cancel. Detach, sure. Okay, and it matches those. Okay. Represents a strictly empty plain object, the empty object value. All right, non-empty objects. Okay, those are straightforward. Represents an object with unknown value. You probably want this instead of an empty object. It's weird that you can't see the examples here. Represents an array. Represents a map. Represents a set, except without certain keys. This is a stricter version of omit. What is this saying? Filter out keys from an object. Returns never of exclude is strictly equal to key. Returns never if key extends exclude. I don't know what those two sentences mean. So returns never. First thing I need to do, I think TypeScript's never is like a throw. The never type represents the type of values that never occur, right? So this is like a return type of never in a function is the expectation is it never returns. Holy guacamole. Which is, in this case, returns the never type if exclude, which filters out keys from an object, is strictly equal to key. So if it equals, I don't actually know what that means. If exclude is strictly equal to key, and key has not been introduced anywhere. So I don't know what the key type means here. There's like other knowledge I need to have. Returns never if key extends exclude. Again, returns key otherwise. Okay, so let's see an example. Filtered. So foo is a string, and it's filtering out the value of foo, and that's never. An object is pretty liberal here because it's a string, not what you would consider an actual like object, like a map. Example, so these are the cases, I guess. Filter, bar, and bar extends string because it's a literal of string. So in that case, you can't exclude a base class, I guess is what it's saying. And then filtered bar foo. Okay, so bar is a value and you can't filter foo from a value that isn't that value. So you just return bar. Okay, I don't know why the examples. I mean, that makes sense because you want to see like a primitive example. I guess maybe you want to see a primitive example. But that is not, if I understand this correctly, how you would ever use this. You would probably use this, and let's see if there's any other examples. Yeah, this is except, right? Yeah. So this is the documentation for it, I guess, is where we're starting. And foo has A and B, and foo without A is just B. Okay. That makes sense. But the initial examples were kind of wild. Okay, whatever. Foo without B, and then you kind of get through it. So, and then, okay, so here we're going to differentiate omit, which is a TypeScript native type, utility type, from accept. The omit utility type doesn't work when omitting specific keys from objects containing index signatures. Consider the following types. Okay, type user data equals metadata, which is a string. Okay, so any key, I think what this means is there is a key, which we're going to name metadata, which is a string, and it returns a string, and then there are these specific fields. Omit clearly doesn't behave as expected in this case. Type post payload equals omit user data email. So the expectation would be name, role, and then metadata string. And it's okay. So this is like a very relaxed version of what you would expect. Okay, so let's try this out. Where do I have? Oh, I have it over here. So this is saying user data equals Where did that come from? Okay, and like, how does that work? So, and then I can do anything else, right? Oh, I see. This needs to be. Okay. And then this is metadata. So I think what this means is I can add whatever else I want. I don't know why. Oh, I can't do that. String only refers to it. Oh, I see. Okay. So, look at this. I am like leaking metadata. Okay. So this just, you need this to indicate that this is going to be a value of string. And if I did like that, yeah. Right. So the shape of this is such that I can only have strings. Okay. Cool. And then this is saying, if I use the default, equals omit user data email, then this guy is, yeah, very generic. It's honestly, I don't even know why it allows numbers. That feels very wrong. Like, why would this be what it is? I think it's because an object can have a string or a number and it just kind of blows up. It says, if you want to omit, and then I guess, if I'm understanding this correctly, if I do that, this works better. Yeah. So the problem is when you add this, like, ability to have any arbitrary key. Okay, and then this is saying cool. Very interesting. I think though, if I'm not mistaken, oh, exclude. Okay, so there's this other thing called exclude, and that has to do with discriminated unions. Okay, writable. Okay, so this makes things mutable, and readable makes things immutable. Writable deep, and deep immutable, and deep mutable. Merge. That's interesting. So foo and bar and foo bar merge foo bar keys of the second type. Okay, so the second type overrides the first. So this is just like an object literal if you're using destructuring inside of your objects. Cool. Okay, makes sense. Merge deep. I wonder when you read these things, like, am I learning something new, or is it that it's like close to my understanding of what you would want? When is it that your mind gets like exploded, right? Where you see something new and you're like, oh my God, that's entirely like, this just feels like it lifts an already existing concept into types. So it's not like you're learning something new necessarily, but you're seeing how, I suppose, something can be applied to a place where it hadn't before. Okay, merge two objects or two arrays, tuples, recursively into a new type. Merge two objects or two arrays, tuples, recursively into an... Okay, fine. So merge deep. Merge exclusive... Create a type that has mutually exclusive keys. Interesting. So it's this set intersection. Inspired by comment. Without. Okay. So is this the example? Exclusive variation 1, exclusive variation 2. Let exclusive options be exclusive options. So 1 works. Oh, 2 works, but you can't have both. Very interesting. So this is saying like you can either... Oh, that's a really cool type actually. Maybe this is one of those moments where you can see the shape. So that means like you can either have an and... Like you can either have what's a good example of this? A good example would be like an anonymous user or a user, but like what's an even simpler one? Square or circle. Right? Maybe this is an indiscriminated union. Oh, I see. It's a completely different... so this would be the discriminator. So this is like a discriminated union based on the shape. So we can say like... I can't even use corners. Or I can use... something like that, and then we can say like something like that, and then what is it? I wonder what the issue is. I feel like I'm not... Okay, 1 is I can probably move this back a bit, but 2 is the desk I'm using is like just a little bit too high for like ideal sitting. And the reason I say that is because like everything else is great. The chair, my legs are like in an appropriate spot, my arms, but then the desk is up a little bit, which makes like the keyboard up a little bit, and then it makes like everything off. Type square or circle equals type fast dot. What is this again? This is exclusive merge. Okay. And then it uses without, and then there's like a typefast dot prettify, right? Or I guess there's not. Okay. But in any event, then it's... And I guess it should be like XOR. But then I can say, interesting, so I can say radius to... Right, and it just kind of blows up because you can't have both. Okay, cool. And then I can remove this, and that's fine. And I can't remove that because you need one of them. Cool. Okay. Very interesting. Override properties. Override properties. Override only existing properties of the given type, similar to merge, but enforces that the original type has the properties you want to override. Okay. Require at least one. Interesting. Cool. Require exactly one. Create a type that requires exactly a single key of the given keys and disallows more. Okay. When would you use that? Right. So you have to choose a response type. Okay. These are very good, like, utility types. Require all or none. Okay. Require one or none. Okay. Single key object. Create a type that only accepts an object with a single key. Interesting. Create a deeply required version of another type. Use required to. Okay, so just levels of it. Pick properties from a deeply nested object. Interesting. How does this work? This is really useful. I guess not. Like there's a weird thing you have to do when you have to get like type values from a library. You have to go through like return types and blah blah blah, because like they may expose only a subset of the things that they use internally, but then you'll need like a subset of what they use, because sometimes you can call functions in a way that only needs a subset of what they say that they need. That's usually a pick. But then there's like, oh, you should have exposed a type, but you didn't. And then you have to do like a return type. And then after you get the return type, you want to do a pick, but then you want to pick through a traversal. And then one of those things may be a function, and then a return type may have like a value. So you end up going through different modes. One is return types based on function calls, and you're nesting through the object that comes back, and then this. So interesting. Address. Okay. Right, so let's take a look. Where is the pick deep? Pick deep. Oh, so you use dots. Very cool. Supports optional properties. Okay, cool. And you can use like multiple pieces. This is a very cool one. And then 0, so this is like a JSON path. Very nice. I guess I can open this in a new tab to not have to like keep coming back to this. Omit properties. Okay. Omit index signature. Omit any index signatures. Oh, really cool. So is that like an array? Okay. Keyed. Pick index. Where is it? Can I just get rid of this? Okay. Okay. Omit index signature object type. Key type in key of object type. Yeah, I don't know. Okay, example. Let's see what we got here. So interface example. Oh, an index signature is anything that defines the index signature. Okay. So all of those are index signatures. Okay. and then omit signature example. Right. So you'll have those explicit keys or undefined, which is interesting. There's probably a reason why you need or undefined, but I don't know what it is. That's cool. Pick index signatures. Okay. Partial deep. Okay, partial. Create a deep version of another type. Partial on undefined. Lock in. Yes, okay. And an alien, 4 aliens are coming to lock in with us. Hello. So all of these are variants. I'm not seeing anything really that new. Partial on undefined deep. Oh, what does that mean? Create a deep version of another type where all keys, excepting undefined, are set to optional. Oh, wow, that's a weird requirement. Why would you use that? So cursive transforming, make all property. Okay, example. So settings, and some values have undefined, and then test settings, partial on undefined deep settings. Okay, and then it redefines option A to be the literal foo. Option B is now optional. Oh, so it makes it optional by setting this to be optional entirely. Right, okay. So instead of it being number, so this is value optional. I believe the way to describe this is you can either have a value or you don't have to, but you have to specify that option B is there. And then this is saying option B now doesn't even need to be within the object. And then sub option, because this is deep, means you don't have to specify something that can be undefined. So in this case, okay, so that's cool. So that's actually very useful. So if someone else defines something and they don't give you the ability to say that the key just doesn't need to be there, if it's going to be undefined, then you can just wrap it with that. Okay. Undefined on partial deep, so that does the reverse. Okay. Read-only deep, yep. Literal union. How many more? There's a lot, hey? There is a lot. That is very cool. But I feel, how many have I gone through? I've gone through some. Okay, and there's many more. Literal union. Create a union type by combining primitive types and literal types without sacrificing auto completion in IDEs for the literal type part of the union. Okay, so there's a bug and then this corrects the bug. So pet, dog, cat, or string. Const pet. Oh, yes. I know this. I think you can do this without using this. Yeah, it's this. So you say string and a record. Like, I think the other way to do this. So here, let's do this. Let's see if I remember what I... dog, cat, or string, and then right, and then you can see here there's like no autocomplete, and I think the way to get around that is to do this. something like that. There's a way to do this where you like set up a type constraint here, which makes autocomplete not does it have it? What if we go to this? Because you don't need this library. Right, there it is. Okay, so you can write string and maybe never. Or object. Huh. Where does it say? Oh, here. So what is this doing? Oh, I don't want to use generics if I don't have to. So dog or cat or the type and the empty object. Okay, I'll try literal union. Two arguments. Oh, I see. Or, okay. String and record never, never. Right. Oh, I see. Did I not? I feel like I did. Yeah, okay, so this is working. So you can do this or this. Both of them do the same thing. But I think this is a better representation, I guess, of what you're trying to do. Because if I don't add this, then I don't get the autocomplete. Let's just presume that's the case. Right. And then if I do what I had, then I do get autocomplete. Yeah, okay. So this is that, and then I guess record never never is just a better version of that. So that's nice. Did I? Yes, I did. I have to open this guy up again. Okay, so we were at literal union, which is around here. No. Partial literal union. Okay. Tag, create a tagged type that can support multiple tags and per tag metadata. Okay, and I may end here once I figure out what this is. So account number, tagged number, account number, tagged number, account balance. Okay, so this is almost like a discriminated union, I guess, where you're saying like it's just a primitive, it's a number, but there's metadata that says that it's an account number or an account balance. Create account number, return to is account number, get money for account number, account balance. Okay, so you're gonna like know that it's an account balance later. Get money for account. Okay, so you can pass functions. That's very interesting. So that puts the semantics into the types. So now you can know that the values you're using here are like being passed around correctly. But this won't because it's not okay. And then because you're pushing this in, this is like a monad, I guess. You're like giving context to a value that inside of it isn't really represented without context. I have no idea if that's a monad, right? Like I remember reading an article a long time ago about monads and saying, okay, cool. Like it seems like it's an envelope you can put stuff into and take things out of. But maybe that's not exactly everything a monad is, and maybe that means this isn't. Maybe it's monad-like. You can also use tag values like their underlying untagged type. Okay, so this, I guess, coerces the two into an account number. This will compile successfully, can be used as a regular number. Okay, so I think that means that it's not type coercion, it's like type coercion or tag coercion. Okay, so URL, special cache key. So this feels dangerous, right? Because you can start putting these in your code in all sorts of different places, and then like instead of just being able to pass a number around, like you've got input and you know the input's a number, but you don't know that it's a specific type of number, and it like just locks in a very mechanistic way that things can interact with each other, which may be good, maybe you want that, but it also feels like you lose a lot of flexibility by doing that. So I think we will stop there. I'm just going to highlight it so we know where we left off. Where did we leave off? Where's tagged? There it is. So we are there next time. Okay, I'm going to go take Claritin because my body is going crazy. All right, have a good one. Later.